Let's be honest. Have you ever really thought about what's in your trash can once you shut the lid? We kind of just think of it as, well, gone. But for scientists and engineers, that's actually where the real story begins. So today, we're going to decode our discards. We're going to look at waste not just as garbage, but as a super complex material that has its own unique story to tell. So, what do they see when they peek into that big, messy mix we call garbage? I can tell you, it's not just a pile of junk. They see clues, they see data, and they see a whole lot of potential, all just hiding in plain sight.
And that's the key, right? It isn't just garbage. You got to think of it more like a resource stream. So, if we want to manage it properly, or recycle it, or maybe even get energy from it, first we have to understand it. We've got to decode its fundamental characteristics. And that is exactly what we're diving into right now.
Okay, so let's jump right in with our first lens of analysis, the physical clues. These are the things you can actually see and feel. Weight, size, and just how much space it all takes up. And trust me, these clues are absolutely crucial for the basic logistics of managing all this stuff. First thing on the list is density. Now, in simple terms, this is really just about how fluffy or how packed down our trash is. Just imagine a bag that's full of crumpled paper and plastic packaging versus another bag that's got old food scraps and glass bottles. Same size bag, right? But a totally different weight and density. So why on earth does this matter? Well, density pretty much dictates everything. It tells us how big our landfills need to be, what kind of trucks we need to use, and even how much a single one of those trucks can actually carry. It's like the foundational number for the whole system. And get this is where the engineering is just brilliant. The compactor on a typical garbage truck can squeeze that waste and increase its density by up to 4 times. That means one truck is suddenly doing the work of 4. Think about the savings in fuel, time, and of course, precious landfill space. It's a game changer. Another huge factor is moisture content, and it's pretty much exactly what it sounds like. How much water is locked up inside our trash? A pile of wet grass clippings is going to have a lot more moisture than a box of dry paper, and this changes like crazy with the seasons. And all that water? It adds a ton of weight, which means it costs more to haul it around. But even more important, if you're trying to generate energy by burning waste, a high moisture content is a huge problem. Wet waste just doesn't burn well. It's basically like trying to start a campfire using damp logs. Just doesn't work. All right, so from water, let's talk about size. Waste isn't this one uniform thing. It's a total jumble of big stuff and little stuff. Particle size analysis is really just the process of figuring out that mix. Everything from tiny food scraps to a bulky old chair. Now, this is absolutely essential for designing the machines at recycling facilities. The equipment you need to separate tiny bits of glass is completely different from what you'd use to shred up a mattress. So knowing the size distribution lets engineers build machines that can actually sort this incredibly complex puzzle efficiently. Okay, we've looked at the physical side. Now let's switch to our second lens and go a little deeper into the chemical secrets that are hidden inside our trash. This is where we start to uncover its potential as a fuel source, but also where we identify some of the hidden dangers that might be lurking within. So there are 2 main ways chemists do this. First is proximate analysis, which basically tells us how well the waste is going to burn. But then there's ultimate analysis, and that goes way deeper. It breaks the waste down into its core elements. And that's how we can spot dangerous things, like toxic heavy metals. And you know what that analysis often finds? Something pretty incredible. It turns out that some of the stuff we throw away is just packed with energy. We are literally throwing away fuel. And a perfect example of this is something called lipids. Now that's just a fancy science word for the fats, oils, and grease you find in food scraps, old cooking oil, and all kinds of other organic waste. So, just how energy dense are we talking? About 38,000 kilojoules per kilogram. That is a massive amount of potential energy, which makes any waste with a lot of fat in it a fantastic candidate to be used as fuel. But chemical analysis also has a much more serious job, finding those hidden dangers. That same ultimate analysis that finds useful stuff can also detect toxic heavy metals, things like lead and mercury. And finding these is absolutely critical to make sure they don't end up leaching out into our soil and our water. All right, finally, let's look through our third and final lens, the biological footprint. This is all about the living, or maybe the once living, part of our waste. We're talking about how it breaks down, the problems it can cause, and its direct impact on public health.
At the very heart of this is biodegradability, which is just the ability of organic waste to be decomposed by microorganisms. But here's the catch. Not all organic material is created equal. Your food scraps might break down in just a few weeks, but things like paper and wood, which are also organic, are much more resistant to decomposition.
And you know, that whole process of decomposition, it leads to a very familiar question. What in the world causes that unforgettable smell of garbage?
Well, it's all just chemistry. As that organic material breaks down, it releases this cocktail of gases. The most famous one is hydrogen sulfide. Yep, that's the source of the classic rotten egg smell. And here's a little fun fact for you. Methane, which makes up a huge part of landfill gas, is actually completely odorless all by itself. The smell comes from these other little compounds mixed in.
But decomposing waste doesn't just create bad smells. It creates the perfect home for pests. That warm, moist environment you find in rotting food is basically an ideal nursery for flies to lay their eggs. This lets their populations just explode if the waste isn't managed the right way.
And this is why it matters so much. It isn't just a nuisance. Flies are vectors, which means they can carry diseases straight from the trash into our communities. They can transmit really serious illnesses like typhoid and dysentery, which makes proper waste collection a critical public health issue. So let's just recap everything real quick. By looking at our waste through these 3 scientific lenses, we get the whole picture. The physical characteristics, they inform the engineering and design of the entire system. The chemical analysis, that unlocks potential for energy and recovering resources. And the biological footprint, well, that guides our strategies to protect our health and the environment. So you see, it all starts with a deep, scientific understanding of the stuff we throw away. And that leaves us with one final thought. Now that you know what's really in our trash, what's one single thing you could change right at the source in your own home to make this whole process just a little bit better?